my way to the core. Okay, roll.
So we're doing the heart rate monitor. It's Mario, Tommy, and Aaron. So we'll start off by answering what is heart rate variability and why. So it's a change in time intervals between adjacent heartbeats. It's also directly related to the body's regulatory systems and ultimately their efficiency and health.
But I think that the pain himself, that's just a buzzword you guys put in there, or does it mean?
Something I found online. So too little variation in your heart rate indicates several symptoms like stress, which is what we're doing. And you can kind of see that here as an example. So you see a lot of variation on the left side and then less on the right.
Alright, so the technique we're using is called PPG, which is that word right there. And we're pretty much measuring the change in blood flow volume. And we're using a pulse oximeter, which will light the skin, and will measure the reflected light to the photodiode. And since blood absorbs a lot of light, if there's a reduction of blood, you'll see like an increase in light intensity. And the AC component of the measured waveform is pretty much going to correspond to the heart rate of the person. And then this data is going to go to the AFE, which is like a bridge between the controller and the sensor. It has like amplifiers and built-in ADC, and it can like filter out signals for you. So we're going to be using that.
So these components we're using aside from the PSOC. We have the AFE 4400, which has everything. It basically, we just attach this guy, the Bioman sensor. It has LEDs here, and it has a photodiode here, which is there's a schematic for it in the AFE 4400. And we just supply 3.3 volts to this AFE, and that should just work fine. And
well, this is just the enclosure that we have for now. You see the bottom, there's that little hole for the sensor where it's gonna measure or that's where the LED is gonna beam on your hand. And we have like also an opening in the top for like maybe like an LED display later on. But that's that, yeah. This is the cost breakdown. The main expensive components are the PSOC, 4BLA, the AFE, and the PCB. And the total cost can be like $44.
And this the current state diagram that we're trying to work with. We have the low power mode, and then after 60 seconds we'll be collecting data, and then we'll go back to low power mode.
So this is our dummy app.
I don't know, keep on going. Keep on going. Keep going.
So we get two screens. First screen, swipe to continue, and then we get a current stress reading with hopefully a weekly stress pattern. That's it.
Yeah, so right now, like, our main problem is getting a working PCB board. We have high hopes for our next one, but that's like what's holding us back right now.
You have high hopes for the next one. What's the problem? It's complicated. Do anything?
Or first one, we just like there was like an air wire, pretty important. And then our second one, there was like I'm not really sure.
Okay, that doesn't sound too good. You're not sure what's going on.
Okay. All right. Next
the